Now we're going to learn a new sequence. It's called geometric sequences. We learned the arithmetic sequences, which is the common difference. And every term and the next term, there's a difference. They're always the same. And this one, we talk about a geometric sequences. What does that mean? Compared with arithmetic, it has the equal difference, and this one they have the equal ratio. Okay, so a geometric sequence is a sequence in which each term after the first term is obtained by multiplying the preceding term by a fixed non-zero constant. Okay, so the amount that you multiply each time, we call that R, and R cannot be 0, and that's the same ratio. All right, the formula looks like this. AN equals A1 times R, and to the power of n minus 1. So which means is A1 is just A1 by itself, and A2 will be A1 times R, okay, and A3 will be A1 times R square. See that? Or you can say that will be just A2 times R. Okay, so the third term will be the second term multiplied by R. And of course, you know the A4, you can either use A1 times R cubed, so each time it multiplied by R, or you can do A3 times R. It's the same thing, so you just keep going. Do you see that? And for the arithmetic sequence, each time we just add D, add D, add D. We do that. And this one, we multiply by R, multiply by R, multiply by R. Okay, it's not too bad. It's not too bad. Now, I ask you to write the first five terms of a geometric sequence. I give you this. I give you the A1 is 1, 0, 2, 4. I give you the R is 1/2. Can you write A1 to A5? Okay. Okay, I keep this little cheat sheet here. So my A1 is 1, 0, 2, 4. And my A2 is 1, 0, 2, 4 times 1/2, which is 5, 12. My A3 is going to be 5, 12 times 1/2. It's always the previous term times R. So that is 256. Good. And A4 equals 256 times 1/2. And that is 128. And remember, I asked for 5 terms. So A5, there's no space. And that is 128 times 1/2, which is 64. See, that's what you do every time you cut in half. So that's like a same ratio or equal ratio or common ratio, and this is a geometric sequence. Okay, and then I ask you, can you find the 7th term? Well, of course, if you do a little bit further, you can find the 7th term. There's 2 ways. You can do A6, that'll be half of that, which is 32, and A7 is 16. So I found it. That's the 7th term. Or you use the formula AN equals A1 times R to the power of n minus 1. So A7, that will be A1 times R. Here will be 7 minus 1. But the good thing is we know A1, which is 1, 2, 1, 0, 2, 4. And we know R, that is 1/2, and to the power of 6. Okay, so which is 1, 0, 2, 4 times 1 to the 6 is 1, 2 to the 6 is 64. So then that answer is 16. Okay, so you get the idea that when I tell you it's a geometric sequence, you can use the formula. You can use the formula to get to nth term right away, or you can just get the term from the previous term just by multiplying the R. Multiply by the R, you get it. So this is the geometric sequence. And after that, I want you to learn how to get the sum of the first n terms of a geometric sequence. Okay, so which is Sn. All right. Well, I don't think you need to know how to prove it, but I can tell you how to prove it. It's fairly easy. And do you remember Sn? That will be A1 plus A2 plus A3 plus all the way to An. Is that right? Okay. So remember, every single term is the previous term times r. So let's do this. Let me just multiply the s by r, and that r will multiply by a1, and r multiplied by a2, and so on. So that will be r a n. Remember, this is a geometric sequence. So a1 times r, that is a2. a2 times r, that is a3, and then all the way. And then this is a n plus 1, isn't it? So this is r as n. So I have this, and I have this, right? If I use this one, if I use, okay, so let me see. Okay, I go this. Let me multiply by -1 here, the whole thing. So I will get a negative r as n equals negative a2, negative a3, and all the way to negative a n, negative a n plus 1. Okay? Make sense? And then I need to add this two together. If I add this two together, I will get as n minus r as n equals. Did you notice that your a2 all the way to an, a2 all the way to an get cancelled? Get cancelled, right? Because positive and negative get cancelled. So I will have a1 minus a n plus 1. But I don't really care about a n plus 1. I just replace this with the formula itself. Okay, here should be a1, and here should be this thing minus 1, so that's n, isn't it, by definition? And the left side I take out, or I factor out as n, and I have a 1 minus r. So can I get a as n now? Yes, I divided by 1 minus r. So as n equals, in the top I factor a1 out, I get a 1 minus r to the n over 1 minus r. This is the formula for the nth term, first n terms of a geometric sequence. You don't need to know how to prove it, but I just think it's fun to do it. But if you like, of course, you're gonna have fun too. So this is the formula for that. If I have a geometric sequence, I have the first one, and then I multiply by r to get the second, multiply by r again to get the third, and keep going until I reach the nth term. So if n is a fixed number, then that is the sum of the first n terms. It's called a series, right? And then what about if n goes to infinity, if n goes huge? Okay, I tell you what, if your absolute value of r, because r could be positive or negative, right? If your absolute value of r is greater than or equal to 1, then there's no, I would say the sum doesn't exist. So the sum does not exist. We cannot calculate that. However, if your r have the absolute value of r is less than 1, which like 1/2, negative 1/3, positive 15/23, things like that, as long as the absolute value of r is less than 1. Now, if r is a number between positive and negative 1 to the nth power, and n is a huge number, you think about a number less than 1, you multiply by itself, and so many times it will always getting close to 0. So 1 minus 0, so this part will be just 1. Therefore, your s will be a1 over 1 minus r. Okay, so this is the case when you have n approach to positive infinity, which means you have a infinite sequence, and then your r has this absolute value less than 1. That's a formula. How do we use it? Okay, I ask you to find the summation of the infinite formula, which is I equals 1 and infinity, okay, of AI. Okay, I tell you, it looks like this. It's 1/2 plus 1/4 plus 1/8 plus 1/16 and continue forever. Okay, I ask you to find this. First of all, you can identify this is a geometric sequence, because every time, what is R? A1 is the first term 1/2, and every time you go from here to here, you multiply by 1/2. From here to here, you multiply by 1/2. So you get A1, you get R. Look, you have the absolute value of R is less than 1. True. Okay, now formula. My S will be A1 over 1 minus R. So that is 1/2 on top. Denominator is 1 minus 1/2. So that's 1/2 over 1/2. Here's the sum. So the summation of this infinite sequence will be 1. Interesting. Okay, I want to show you what do I mean. Okay, this is a square with a side of 1. Okay. Where is the first 1/2? I'm going to show you that this is 1/2. Isn't it? And what about 1/4? 1/4 is half of that. So this is 1/4. Okay? This is 1/4, this is 1/4. So here is 1/8. Isn't it? I keep adding. Okay, I added this area, this area, this area, and then this is 1/16, and this is 1 over 32, and this is 1 over 64, and here is 1 over 128, and here is 1 over 256, and here, da, 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 da. Okay, so if I keep adding this, if I keep adding that, I will approach, the whole area will approach to 1. Isn't it interesting? I just think it's fun. I always think math is fun. Again, you know, I know you love math, you just don't know how much you love it. All right, good luck.